Hello students, I am going to show you the explicit trade model that we looked at in class today as we were scaffolding from using the direct physical models to the standard algorithm. Remember, this is the in-between that you would just demo to your students to show them how the notation works when you are working toward the standard algorithm. So you start out with a problem like 583 divided by 4. We're going to write this out physically, depicting 583 with the physical models that the students were introduced to from the beginning when they were working with place value. So they're very accustomed to these. We use boxes for our hundreds, we use bars for our tens, and we use the dots for our ones. So we've depicted 583. We're dividing this into 4 groups. What we're going to do is we're going to show the students on one side how we model this just physically. So we're going to create our 4 groups. And on the left-hand side is where we're going to show the explicit trades within the context of the division notation that is part of the standard algorithm. So we have our dividend of 583 inside our division symbol and our divisor on the outside of 4. As we're modeling everything being distributed into their groups over here, we'll record over here so they can see the parallel. So we say how many of these hundreds, the 500s, because there are 500s here, how many can go evenly into each of these 4 groups? Well, we can put 1 into each of these groups. So we'll put 1 square into each of these. As we do that, we will record a 1 right here, and we will cross out 4 of these. We have 100 left. Since there's only 100 left, we can't put any more evenly into these groups, so we trade it. We trade it for what? We trade it for 10 tens. Okay, so now we see that physically we have a total of 18 tens. How do we reconcile that over here? Well, let's do the math first. We know that we had 1 left over 100. So you show the students that since you placed 1 into each of these groups, 1 times 4 is 4, you utilized 4 of those, you had 1 left over, which they saw. You trade that for what? You trade it for tens. So now this 100 becomes 10 tens, and it's added to the 8 tens that are already there. And if you had this on a column sheet or grid paper, everything would be kind of nicely aligned. They're going to trade this 100 for 10 tens and have a total of 18 tens, which they see here, but this is just the recording spot. So we're going to take these 18 tens and evenly divide them into the 4 groups. We can put 4 into each of these 4 groups. So we write our 4 bars. We do the recording here. We put 4 into each. So that was a total of 16. So we're going to cross out these 4, cross out these 4, and then we're going to cross out 4 here, and this little guy, and then just 3 more, meaning that what? That we had 2 left over. So I'm just going to circle that because it can get a little messy. As I mentioned in class, we demonstrate this. We don't necessarily assign this because it might be too much for students to organize. Okay, so they have put 16 total in the groups, and we get that over here because we see that, hey, we put 4 in each of those 4 groups. That's a total of 16. 18 minus 16 gives me 2 leftover tens, which I see right here. I cannot distribute those anymore because I have 4 groups and only 2 tens, so I make an explicit trade. Those 2 tens are going to become 21s, and I'm going to add them to the 3 ones that are left here, so I will have 23 ones total. And we demonstrate that physically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 20 plus the 3, that's 23. We can put 5 of those evenly into each of these 4 groups, so we record that. We record that up here. We put 5 evenly into each of the groups, meaning that we've used 20 ones total. We should see that we have 3 left over once we cross out all those that we've used. We've used those 10, we've used those 10, we have 3 left over. There's your remainder of 3. So this is the explicit trade method that we see will connect very strongly with the standard algorithm, but it's nice to do this recording initially so the students see the direct connection between the numbers you have here and the physical models that you have here. This is a lot more writing and it's harder to keep organized. So once you have done this a couple times and modeled for the students, you can say, hey, I have a shortcut, and then just introduce them to the standard bring down method and let them see that, oh, when I bring down my 8, it pairs with the 1, that gives me the 18, which I see here, that it lines up, that they get the same exact numbers. But now they know where those numbers are coming from because they were able to see those physically over here. But that is the example that we looked at in class. Hopefully this was helpful and it will reinforce what we looked at.